we're going to get started here after the break. Anis Kadri is going to be talking about the evolution of JavaScript programming. Anis, longtime PhoneGap member. He was on the team that originally started PhoneGap back in Vancouver, BC. All right, Anis, take it away.
Thank you. Thanks. Good morning. My name is Anis, and I'm here to talk to you about how asynchronous programming has evolved in recent years, hopefully for the better. We will cover some of the tools that we use to program asynchronously in JavaScript. So we'll start with callbacks, and then we'll talk about promises, and then we'll spend some more time talking about the newest addition, that is async await. So let's start with callbacks. So callbacks were the original way of handling asynchronous code in JavaScript. They're used all over JavaScript. We use them for event handling. So as an example, when you have a click event, you pass in a callback to handle that event. You pass it to add event listener. We also use them in set timeout, set interval. And we also use them for XML HTTP requests to handle responses. So callbacks are passed in as arguments to high-order functions. And high-order functions is just regular functions. But yeah, callbacks are passed in as arguments. And callbacks are great for customizing, extending, or they're also good for code reusability. So if you have a function that does pretty much what you want, but not exactly what you want, you can pass in a callback to customize the behavior. And then, yeah, reusability is because when you have a function, it's a function, so obviously you can reuse it in multiple places. Callbacks are not to be confused with closures. Closures can be callbacks, but callbacks are not necessarily closures. Closures can, could require like a whole other talk, so I'm not going to cover them here, but yeah, they're basically functions in functions. And you can define callbacks as closures, but it doesn't have to be that way. So callbacks are great, but they're not so great because of this concept called callback hell. And it caused a lot of people to say that asynchronous programming was hard in JavaScript because of this callback hell. There's actually a website that describes this thing. So I'll let my childhood friend define it. So basically, when you have a callback, you can add in another callback, and then in that callback, you can add in another callback, and then in the end, you ended up with this like impossible code to read and maintain. So in this case, I have like 4 different functions that run asynchronously. And each one of them takes in an argument and a callback. And in the first callback, you have to basically handle the error and then call the next async function. And in that async function, you repeat the same thing and over again until you finally call the initial callback that was passed in originally. So this gets very messy very quickly. When I look at this, it's basically looking at, why so asynchronous? It's basically looking at a staircase where you don't know where it starts and you don't know where it ends. You just like try to find where the error is or like where the code executes, and it's really hard to find the thing you're looking for. So because of this callback hell issue, something was introduced to facilitate asynchronous programming, and that is promises. So promises were introduced in ECMAScript 2016, I believe. And they obviously make code a lot more readable, a lot more composable. There's less nesting involved with promises. You don't have to manage errors at every level. You can just pass in a catch statement and then give it a callback, like an error callback. However, I don't think they're not that different from callbacks, because at the end of the day, you're still using callbacks. It's just that they're used a little differently. So the syntax is a little different, but you still you're still using callbacks. So let's look at the same example with promises. So in this case, we have the same functions that are executing, but instead of taking in a callback, they return a promise, and you can manage the the results by passing in a handler. So in the first case, we're calling the async function, taking in the argument, and then in the then statement, that's when you pass in the callback. So instead of passing it as an argument to the do something function, we're just using the then statement and passing in a handler there. And you repeat the process. So as you can see, if you are programming on a terminal that has 80 column limit, I don't know who does that, but just in case, you can actually view and see the code using promises. And then we have the catch statement at the very end that handles all the errors. So I feel like most people are familiar with promises, so I'm not going to spend too much time. There's also another way to manage asynchronous code in JavaScript, and that's Rxjs Observables. Anyone familiar with Rxjs? Or people? OK, cool. I'm not going to talk about them too much, mainly because they're not standard, and they add a lot of code to your bundle size. They're pretty good for complex flows and also data streams when you have like more than one value that needs to be returned. If you need more information, you can go to the link. I think the presentation will be available after the conference. But yeah, obviously, if you're a React person, you're pretty familiar with them. I'm not a React person, so I'm probably the last man to ask about Rxjs Observables. But just know that they're there, and they could be pretty useful. So let's dive into async await, which is the newest addition to the JavaScript language. Is anybody using async await? 2 people? 3 people? OK, cool. So in my opinion, they're like the most revolutionary addition to the JavaScript language in recent years. And you'll soon see why. The same example, which was, in my opinion, very messy, can be achieved using async await, just like so. So in this case, we define what we call an async function that takes in an argument. And then we write the async code just like we would write synchronous code. So we define a variable, and then we execute the first method, the first async method, and then we await for it. So basically, we wait for the result to get back. And then with the first we pass in the first argument to the second function, and we get the second value, pass into the third function, get the third value, and then fourth. And then you can just return the fourth value. And I feel like this is like super readable, super easy to understand. And then the upside too is that you can use a good old try-catch block to manage errors. So if anything happens inside one of these functions, you can just catch it at the bottom there. So it's very good. Like compare this to the callback nesting that we did earlier. This is like so much easier. The thing to know as well with async await is that we are still using promises, and we still need to return a promise. And async functions can be defined as statements or as expressions. So if you want to define an async function as a statement, you just prefix your function with the async keyword, and then you just write the code in that async function. And then if you have any long-running tasks, you can await for them. So you prefix the functions with await, and then you just return the result, which is also a promise. And then whatever result you return, it's obviously a promise. So you can call then on that, and then handle the response in there. So in this case, we're just console logging the result. But they also can be defined as expressions. So if you want to use an anonymous function, you don't have to give it a name. You just define async function, and then run the code in there, and then just manage the response in the handler. Yeah, one more thing to add is that await only makes sense inside of async functions. So you can't just call await in the global scope, because that's not going to work. It has to be defined inside an async function. So they're also great for error handling. So in this example, we have a function that uses promises. So we're just fetching some data from some remote server, and then we're parsing that data, and then just like console logging an attribute from the object. And then JSON.parse could raise an exception, and we're handling that in the catch statements, and just console logging the error message. So that's for promises. And like I said earlier, with async await, you can just use a try-catch block. So we're writing the same code, but instead of using a catch statement, we just write the try block, run the code in there, and then if there's an error in the parsing, we just catch it. So it's just a lot easier to manage. So async await are also great in handling intermediary values. So I don't really run into this scenario very often, but you might run into it. So in this case, we have 3 tasks that need to execute in sequence, and the last task actually uses the values from the first and second task. So in this case, we have to actually nest promises. You can change the syntax of this, or the semantic of this, by using promise.all and passing in an array of values. So it's the second part of this slide, it's a little more readable, but I don't know. I feel like the semantics of it is harder to understand, because you're just seeing that we're using an array of values, and we don't really need to do that. The only reason we need to do that is because the third task actually uses the 2 values. So it's more readable, but it's a little harder to understand. But we'll see how this works with async await. It's so much easier. If you want to get the first value, just execute the first task. You get the second value of the second task, and then you return task 3 with both values. It's hella easy. The other reason you want to use async await is because conditional statements are a lot easier to write with async await. So in this case, we have an example with promises where we need to get some data from a server. And then depending on the data, we might need to make another call to the server. So we have an if and else statement. And in the if statement, we get more data, and then we have to pass in another callback that handles that data, and then we console log that data, and then we return the data. And in the other case, we just console log the data and then return it. But this can get pretty messy pretty quickly. And then with async await, you just write an if and else statement like you would write an if and else statement for synchronous code. So if you need to make another call, you just make it and just wait for the data to get back, and then you just log it and return it. And if you don't need to make that call, then you just log it. Super easy. So debugging. Async await are also great for debugging, because when you have an error in chain promises, it's basically managed in that catch statements and inside your error callback. And when there's an error, you usually get it wrong because you don't know which then statement is actually responsible for the error. But with async await, or especially with await, you can just see where the error is, because it just points you to the line number. The error stack will point you to the line number where the error lies, and you can just you can just fix the issue there. And when you're using a debugger, you can just set breakpoints and just step through the function just like you would with the synchronous code. That really doesn't really work, with chain promises. So that's a huge benefit. So to sum up, I think I've got a minute left. Async await is a new addition in ECMAScript 2017. It's supported pretty much everywhere except where the smiley is, so no Internet Explorer. But it's supported in Edge and Edge Mobile. It's also supported in Node 8. I think 7 and 8, but 7 is unstable, so 8. And then it allows you to write synchronous code like you would write, asynchronous code like you would write synchronous code. So super easy to read and understand. So when you're using async await, you're not getting rid of promises. You still use promises, and you still return promises. But it's just a lot easier to manage. And then, as I said earlier, await has to be used inside of async functions, like no using of await, in the global scope, because that doesn't make sense. It allows for better error handling, better debugging, and more readability. The only downside is that it becomes harder to spot asynchronous code in your code base when using async await. Like when I look at deeply nested callback, it usually just jumps at me, like I see it. With async await, you basically have to look for the keywords because it's not that obvious. That's it. Thank you.